My name is Catherine Stafford, and I'm a senior in electrical engineering here at Indiana Tech. So my project is a Braille keyboard that I have named BraiKey, and what it is a keyboard that interfaces with a PC-type device that's like your computer or a laptop, and you type in Braille rather than in standard English. So Braille is made of a matrix, so there's 3 rows and 2 columns. So if you were to swing your hand out, you now have a row of 6 keys, and each one of those, for the sake of my code, I have given them letters, and then different combinations of those letters will create different inputs for the keyboard. So as part of this, I needed to design the case, and I haven't done a lot of 3D modeling, and it's not something that comes particularly easy. It's kind of complicated, and I spent many hours modeling and designing and tweaking and adjusting and measuring, and it was really fun. And seeing this case kind of grow from nothingness into this product was very enjoyable for me, and I hadn't really expected that I would enjoy it as much as I did, and that was a pleasant surprise. So this is BraiKey, and some of the components on here, we have our keycaps. So these are where your hands sit, and they are curved so that it's a more natural feeling, because for me it was important that it also have an ergonomic feel, which means that you can use this for a long time and it's not going to hurt you in the long run. Another thing is, if you have trouble seeing, it's hard to know where your hand is placed on the board, so all of the keys have a different shape to them. Functionally, your home row have this arched doorway appearance to them, and then the function keys, or the extra keys on top, are square. The arrow keys are triangles, and then the space bar is just long and rectangular. With that, we have the PCB board itself. So this is the circuit board. This was also etched in-house and is entirely my own design. And this was done on our PCB etcher. A lot of different things that we can do with it. One of the cool things for me was playing around with the text. So I have text on the board. The flip side of it has the Indiana Tech shield, which was very cool for me, trying to transfer an image into a circuit, because it's not natural for the program to do that. So that was also a cool little side project for me to learn how to do. And the brain of this operation is an Arduino Pro Micro. The Arduino here is programmable, which is very cool for the user, because that means if the user wanted these keys at the top, which on a standard keyboard might be your function keys or hotkeys, you can program them. If you didn't want to type the, you wanted to have a hotkey for it, you can just hit it and you have a the. So this was actually one of the last additions, which sounds counterintuitive. You would think the brain is one of the first things you would pick. The first thing I picked was actually the keycaps. I wanted them to be tactile and have a sound and a feel to them, so you know when you hit a key. Because if you don't have the visual cue of seeing it go down, you want to have the feel of it. I mean, Braille is a textural language. It's raised dots, so the feel is important. And so I actually picked my keycaps first. But I think that the sound has an advantage for someone who may have a hard time seeing or can't see at all. So at this point, I've wrapped up my senior project presentations, and classes are coming into finals week, and so the next big thing for me is commencement and graduation and walking across the stage. And I am really excited for that. I think it's a cool little moment to appreciate what myself and all of my classmates and all of my graduating class have done for the last 4 years. A little nod of, we made it. Get my degree, complete this, get through that finish line, and really top off this experience and move on to the next chapter.